Okay, so let's do a quick one here of using the lowest common multiple to speed up two questions for you considerably. Now, y minus y1 equals mx, x minus x1 is a format we use a lot at A-level. So if I do the above question using that, I would get y minus 1 equals 3/4 of x minus 2. So we can sort of do that one there. What's the idea here then? Well, when we have this format and we're working with parallel or perpendicular lines, we often end up with fractions. In fact, there's loads of other settings as well where you will often end up with fractions. No denominator, no denominator. This is sort of one big product. So the 4 means I'm going to just multiply everything by 4. Okay? And if I did that, I would get a 4y plus 4 equals, this would become a 3x minus 2. So it's quite a convenient step to quickly kind of speed things up. 3x minus 6. Let's just finish off the question now, shall we? So 4y equals 3x minus 6 minus another one, so 3x minus 10. And y equals 3x minus 10 all over 4. In mx plus c form would be y equals 3/4 x minus 10 over 4 or minus 5 over 2. Okay, so really it's just sort of knowing that, and there may be other situations here, I could make the question a bit more difficult, but multiplying by the lowest common multiple will speed it up. In fact, let's just practice that with a slightly different example. Imagine I had gotten a y value of 3. I might have something like this. I think this was x minus 2. So what number might I choose to multiply by? I could do 4, I could do 3. So really what I should do is I should do 12. That would mean that in one fell swoop, I would have 12y minus 4 equals 3x minus 2. So from there, I could solve the question really, really quickly. It's not only with the equation of a line. Cosec squared. Cosec squared is going to be 1 over sine squared x plus sec squared is going to be 1 over cos squared x. So the idea we just talked about is sort of having a lowest common multiple together. So something slightly different, but if we were going to do that here, what would we need? We would need a cos squared x on top and bottom, and a sine squared x top and bottom here, which is going to give us one of the results talked about in another of the videos this week. So our numerator is now sine squared x plus cos squared x. And what are we over here? We are over sine squared x cos squared x. Well, we know that sine squared plus cos squared is a result that is the same as 1. Okay, so how are we now going to get towards this? It's not obvious at all. The thing that stands out is there's a double angle. Cosec is related to sine, isn't it? So something to do with sine 2x maybe? Let's try 1 over sine x cos x all squared. Why? Because this is related to the sine double angle rule, isn't it? Remember that sine 2x is 2 sine x cos x. So a half sine 2x would be equal to sine x cos x. So let's put that result in and let's go up here. So 1 over a half sine 2x all squared. When lots of fractions being stacked on top of one another gets confusing, something you can do is you can sort of think about writing it out. That's going to be a quarter, isn't it? And that's going to be a sine squared 2x. So if I wrote it out, 1 over a quarter sine squared 2x, I might want to multiply by the reciprocal instead, which would be 1 multiplied by So not the easiest one to do. Maybe if I sort of put the 4 in there, it might be slightly easier to see. So 1 multiplied by 4 over, I forgot my 2 there, 4 over sine squared 2x. And we're getting there, aren't we? So 4 over sine squared 2x, which is the same as 4 cosec, the third letter is an S, cosec squared 2x as required. So there we go, a much harder one, but again, working with our lowest common multiple in a trig fractional sense comes in handy.